Lesson 10.1, Simple Quadratic Graphing. This will tie in a little bit with the previous unit because there'll be factoring that pops up later, but for the current affairs, we're just going to do some simple graphing. So a quadratic function looks like this. And like I said, it looks a little bit like the stuff you factored recently. What does it look like? Well, a typical quadratic is a parabola. It'll look something like that. And the point right at the bottom is called the vertex. We need to know that when we graph it. Comes in handy. And another important thing is that it is symmetrical around an axis of symmetry. And that axis of symmetry is a vertical line that goes through the vertex. And when we say symmetrical, that means if I took this side and folded it across the line to this side, it would land right on top of itself. This will be handy when we want to graph it later, but for now, just understand that it's perfect shape, same on one side, same on the other. Where do we find this in nature? Well, the reason we do quadratics in math is it pops up all the time in science, because in nature, if you take an object and throw it up in the air, it will do a parabolic path and then hit the ground. So anything that travels, airplanes, cars, anything that travels and is affected by gravity has a quadratic function in it somewhere. That's why we make such a big deal about it. Now, the quadratic y equals x squared is a special one. We call it the parent function. We call it the parent function because all other parabolas are going to be based on it. To graph it, you can use your calculator, or you can use a simple t-chart. Go x, y. And it'll look something like this. And again, it's symmetrical, so what we do on one side, we have to do on the other. So there's a parabola. Now, what we want to do is take that parent function, the y equals x squared parabola, and then just modify it. Because if we sat down and did tables all the time, it'll make us crazy. So I'll start to give you some ideas. We're going to put the parent function in. And then we're going to adjust it based on what's required. So parent function goes up through 1 and 4 there. It looks something like this. And now, what does, put this one in green, y equal 3x squared look like? We can sit there and make a table. And notice that it goes up much faster. We could put it in our calculator. Could do this, could do that. What we're going to do going forward is make your life as easy as possible. Make this one in purple. This one's going to look something like that. And I know that without even making a table from practice. We'll tell you why it does that in a minute, but the big question I want to know is what happened to the negative out in front of the negative 1/4? Well, that flipped it upside down. And that's a big deal. More on that later, but make sure you're clear on that. It flipped it across the x-axis. Made it upside down, made it face down. And we'll come back to that. So, moving to the next page. We showed you a few things that happened there, and I'll tighten them up in a minute, but what if there's a +2 hanging out here at the end? Now I'm going to be really lazy. Put the parent graph in like this. And then let's go back to green and put the new one in. We're going to go up 2, and it's going to look exactly the same. It's just going to be up 2 higher. There should be a little more curve on these, so let's try and fix that. I'm not going to redraw the parent function, though. Tough. So we notice it went up 2. Notice I didn't make a table. Why? Because I've done this before. You should do a table the first time, but I'll show you all the tricks, so it'll save you some time. A much smarter way is to put it in your calculator and see what happens when you change the graphing. So, remember, here's our function. Y equals ax squared plus bx plus c. We're not going to worry about this now. We are going to worry about the a, and we are going to worry about the c. So if a is greater than 1, like the one we did before, 3x squared, the parabola is thinner. How much thinner? Don't worry about it. Just make it thinner. We're trying to get a general idea of what happens to the graph when we mess with it. The best way to think about this is it's like it has a steeper slope. Remember, if we had a slope of 1 and then we went to a slope of 5, the line got steeper. This is a slope of 1. That's a slope of 5. So it went from here to here. Same thing on a parabola. The graph moves inside of the other one. If it is a fraction, just like here, 1/2 would be like this, it gets fatter. And they've got all sorts of nice technical terms. It becomes horizontally or vertically or horizontally expanded. I just like to say fatter because that helps me remember what it's actually talking about. If there's a negative out front, it flips upside down. Technically, we say it flips across the x-axis. But I will live with upside down. That's fine with me. And if there's a c value, again, we're just dealing with the a and the c for now, it moves up or down. Up if it's positive, down if it's negative. So, want to put all this together. Want to be lazy, but want to actually understand what's going on. So here's our graph. And we're going to just ballpark our parent function. Get it in there, about here. Again, I want to make it a little more curvy. There we go. So that's our parent function. Now, what's going to happen? And we're going to dot it in until we get it. What is the 2 going to do? Well, if you recall from before, it's going to make it thinner. What's the negative going to do? Again, if you recall from before, it'll make it upside down. What's the 2 going to do? It's going to move it up. So do them one at a time. Thinner. And I dot it because we're not done. It's just a starting point. Upside down. And then up 2. And there's our final graph. And that's how we're graphing parabolas. Just getting ballpark ideas. If we want to be precise, we would have to put a table together, label values. We'll talk about how to actually be more precise as we go forward, but right now I want you to get a general idea of how parabolas work and how to graph them. Good luck.